Hi, I'm Tori Noquez. Thank you so much for checking this out. This is the automatic magic square. I'm going to start by explaining the method to performing this effect, and then we're going to talk a little bit about the mathematics behind how this amazing routine actually works. So, to start off, you need to have this square ready to go. So there are a few different ways that you can approach this. In my performances, I have this written down a few sheets into a notepad, and I just keep that hidden from the spectator until I'm ready to begin my performance. Alternatively, you could also memorize this square and write it from scratch. But as long as you have these 12 of the 16 squares filled out. So notice there are 4 blank squares still here. And that's how you will account for the spectator's chosen number. Okay, so in my presentation, I have this ready to go. And then I open up my notepad and conceal it from the spectator and ask them to focus on the number they've chosen. They have not yet revealed it to me. And I'll just pretend to write, I'll draw the square and pretend to write down some of these numbers and usually explain that these are the numbers that they're transmitting to me, or that I'm getting a vibe that these might have something to do with the 2-digit number that they chose. So this sets you up to add the necessary information for this square to represent the number that they've chosen. All right, so here's what you're going to do. I'm going to label these blank squares with letters. I call them A, B, C, and B. Okay? So here's how you'll fill out the rest of your square. They will give you their chosen number. For example, if your spectator chooses 55, so the chosen number, oops. Okay, so say they choose 55. Now the only calculation that you have to perform is subtracting 21 from this number. Now this becomes very easy with a little bit of practice. You can do it in 2 steps. You can subtract 20 and then subtract 1 if that's easier. Okay, so in this case, if I subtract 21 from 55, I'll be left with 34. Okay, so now 34 is going to be my base number. And the reason that I labeled these empty squares in this way is that's the order you're going to fill them out. So square A, you'll put in 34, okay? Then as the letters increase, you will increase this number by 1 each time. So in square B, you'll put a 35. And in square C, you'll put a 36. And in square D, you'll put a 37. And this is all you need to do. Your magic square will be complete at this point. And then you can reveal to your spectator that the 4 rows will add up to 55, the 4 columns, the diagonals, these corners, the 4 boxes that you get in the corners here, like this, the 4 corners themselves, and even the center box here will all add up to their chosen number. So usually at the end, I like to write the number at the bottom of the square, and then I tear it off my notepad and give it to them as a souvenir. So let's talk a little bit about the mathematics behind how this process works and how this yields this amazing magic square. Here's how I like to think about it. Now, we labeled these squares, so I'm just going to go ahead and label their corresponding rows. We'll focus on the rows for the time being. So A was in this row, B was in this row, C was in this row, and D was in this row. Okay? Now, when you have your spectator choose their number, let's call that N. So this is the chosen number. Okay? Then the calculation that you perform is to do N minus 21. So that's some number. Okay? And that's the number that's going to go into position A. So let's label that A. Okay? Then from there, you're adding 1 each time to get to each successive entry. So 1 more than N minus 21 will be N minus 20, right? You subtract 1 fewer than you did in the previous step. Or for 1 more than that, it'll be N minus 19. And then 1 more than that will be N minus 18. So these are actually the 4 entries, so you could get them all directly from their chosen number N. Okay? So here's how this works. And again, we'll focus on the rows for the time being, but the same exact logic can be applied for the columns, for the diagonals, etc. So let's investigate this. So if we look at the existing entries in each row, let's start with row A. Okay, so let's add these up. We've got 11 plus 8, which is 19, plus 2, which is 21. So the entries that are already here are 21. So if I plug this number into here, that's n minus 21. So n minus 21 plus 21 will be equal to the number n, okay? So the 21 that's being subtracted off of here, they'll be made up for by these other numbers when you add them all up. So that's how you get a sum of n in this row, okay? So that same logic applies to the rest of the rows as well. So in this row, 1 plus 12 is 13, plus 7 is 20, okay? So then if I put n minus 20 in this position, that will add up to n because of this 20. The 20s will cancel. And similarly for this row, for row C, if I do 4 plus 6, that's 10, plus 9 is 19. So the C entry is going to be n minus 19, so we get n in this row. And then finally, for the last row, for D, I do 5 plus 10 is 15, plus 3 is 18. So I get 18 in this row. Okay, and then I plug in n minus 18, the total sum will again be n. Okay, so this method is really nice because once you have this number, these ones are easy to find because you just add 1 each time. But because of the way this is set up, all of the rows are ready to go to cancel out and give you that number n back. So here's the amazing thing about this setup though, is it's not only the rows that this works for. You can also investigate the columns. So again, if I label these columns as saying, okay, entry A is going to happen in this column, well, it needs to be the case that these other numbers add up to 21 to cancel out this negative 21, which they do. So if I do 12 plus 3 plus 6, it's equal to 21, okay? And then similarly for the rest of these. So B happens here. So 11 plus 5 plus 4 is going to be 20. So your n minus 20, which is going to live right here, the 20s will cancel, so you get back n. And then C goes here. So same thing, 1 plus 8 plus 10 is 19. So your n minus 19 going here will work. And finally, D falls in this column. Okay, so 7 plus 2 plus 9 is going to be 18. So to put your n minus 18 here will give you 18. Now this also works for for each of the 4 squares and the 4 corners. Okay, so for example, this corner, okay, you know that the B entry goes here, and you know that 1 plus 11 plus 8 is going to give you 20, which corresponds to your n minus 20. Okay, so you can try this out on your own with the other things that whose sums give you that chosen number n, right? You can try the diagonal. Well, 8 plus 3 plus 9, that's going to be 20, and you know you have this n minus 20 here. Or if you look at the 4 corners, right, you get 4 plus 9, which is 13, plus 7, which is 20, so you've got your n minus 20 here. So any of the patterns which an empty square appears in, you can check that the remaining 3 squares are not only all filled out, but they all add up to whatever you're subtracting from n. So that's why you always get your number n in any of these patterns that show up in the magic square. So another idea for how you could present this, if you don't feel up to memorizing this whole grid, which is completely reasonable, or you feel uncomfortable pretending to write on a notepad, one thing you can do is to copy this down lightly on a piece of paper with pencil, or to make an impression of it through a pad of paper, and then just fill it in as you're reading your spectator's mind while they're thinking about their number. The point is that before you have the spectator reveal their number, you have this much information available. And then you can fill in these final 4 squares very rapidly. So that's it. That's the mystery of the magic square. I hope you guys have fun with this. If you're enjoying it, please leave a review on our page. I'm Tori Noquez. Thanks again for checking this out.